All right, let's go ahead and get started. Thank you for coming. My name's Robert Reinhardt. I've given this session, this how-to on identifying real-world playback options a few times. I keep updating it, and there's not a whole lot new that I have to say from West when I gave this presentation at West. As I was joking, as I was waiting for people to come into the room, do comment, send your comments online, put your comments into the social feeds out there. We have SM East as a hashtag. I just tweeted that I was starting here at Murray Hill West. If you're at a session and you like it, feel free to put some comments out there. And of course, fill out the evals that they have available. I've recently taken the position of co-chair of the Video Engineering Summit. It's a brand new track here at Stream Media East and West. We had a lot of success with it at Stream Media West. So if you haven't looked at the schedule for the Video Engineering Summit, please take a look at it. I'll be in that room most of the conference time. Jan Ozer and I are co-chairing those sessions. And again, since that's a newer track, I'd love to hear your feedback either directly to me. If you have ideas, if you want to present at the next one, please let me know. We love to get new takes on the content that we're delivering here. Just some quick contact information if you want it. My slide deck will be available. I'll get it to Eric, so it will be up there with the rest of them. Admittedly, I don't have a lot of show and tell in this. This is more of an information session, QA afterwards, and we'll go from there. I do write a regular column called The Video Doctor for Stream Media Magazine, and that's usually in each issue as well, in addition to feature and hardware reviews. I do a lot of live event production. It's a growing part of my business. I'm based in British Columbia. I spend a lot of my time between the States and Canada because I have clients on both sides of the fence. No border wall there yet, but I'm waiting. Let's see here. What does real world mean? Real world to me means that it's available today in the tech stack. It's not something you have to wait on or know if it's going to be supported somewhere, and that the cost is viable. I have a lot of clients that come to me, startups particularly, that are very cost sensitive, and long-time clients that I've had for over a decade that I used to be a Flash dev in a previous life, and it's still a tricky transition right now in terms of people who invested a lot in Flash-based infrastructure that are still getting as much out of that investment as they can before the death knell really comes down on Flash, which is supposed to be next year. Some statistics. These are the same statistics I presented at my session last year. It's hard to find up-to-date statistics on this. There was some bandied about by the Hulu keynote this morning, but the bottom line is live streaming isn't going anywhere but up. More and more people are watching live content. But as we were joking at one of the events yesterday, just because you can live stream doesn't mean you should live stream. There's a lot of live streams I'm sure that you've seen on Facebook Live that are either just badly produced or just not necessary because they haven't done their due diligence on what they're trying to accomplish with their live streams. I'm not here to talk about content. This is more of a technical how-to, but it'll be interesting to see. I think we could lose interest in live streaming, at least from a user-generated content point of view, if it doesn't become engaging content on one level or another. I'm amazed. Like I do a lot of testing on my fishing boat in the Pacific Northwest, and at how many people will come and watch me stream from my boat. I try to be as energetic as possible when I'm out there, but I don't necessarily think I'm that engaging, but enough people stick around and watch me to stream, and especially if I'm talking about gear that I'm using while I'm fishing. And so that's just a sort of a test case for me. It's again, that's a very niche market, but anyone who's got something to say can be live streaming with it. This is just a little joke on the fact that most of my clients, at the end of the day, we're using RTMP for ingest and HLS out for for our content. It doesn't matter if it's live or VOD. Again, most of my clients want some cost-effective solutions around what we're building out, and keeping track of too many different formats and different codecs. It's just not part of the pipeline that I need to design for my clients. I don't have Google-sized clients, but I have content people that are growing content, whether they're legal professionals. We're still at a critical point, I think, in video history, or if I can use that term. So many people aren't archiving their events. I love that Stream Media records this session and every session out there. It's easy to find. They've got, you can find that content, and most people need, when they come to me, like just for a live event production, I've got all the things set up to do a live event stream, and I do it well, if I do say so myself, in terms of redundancy and making sure that that live stream isn't going to be not seen by the people who are trying to tune into it. But it's amazing to me how even my government clients that have I've been doing live streaming for the BC provincial government for probably over 5 years now, and there's no one central place in that government to find their broadcasts. And so I just started a project with the NIH, the federal agency, National Institutes of Health, and I'm actually amazed at just to throw it out there, if you go to videocast.nih.gov, you can look at so much medical content online just through that portal. And it is well organized. So, I mean, it's very deep medical health kind of coverage, very specific doctors and panelists talking. And I'm actually, we're moving to a system that's as simple as this for the NIH. They don't need low latency, but they do need live delivery. They have VOD archives from their live streams, and we're streamlining all of that. It was old architecture. It was all built on Adobe Media Server and gradually bandied onto over the last decade and a half, and now they've reached a point where they can revamp the entire server-side architecture. So I'm just going to go into the players right now. And when I say players, I don't mean video players. I just mean the characters on the stage right now. And of course, as I mentioned already, HLS, and I'll put Dash out there as well, because it's part of that same model, and CMAF is changing this landscape. I don't have CMAF as a dedicated slide in this option, or in this session, but CMAF is going to play a huge hand in making HLS and Dash a much more universal format or delivery mechanism. I hope everyone in the room knows what CMAF is. If you haven't, I think David just before me talked about CMAF, and there's plenty of CMAF sessions here, but it's basically allowing, it's one of the main reasons I used a tool like Wowza. Wowza took care of my CMAF needs before CMAF was even a luxury. So the idea of having just one encode for each rendition that you want to serve, and not having to have different containers for all your video formats is what CMAF is all about. You still need different manifests, but your source video or your source video and audio can stay in the same container formats. Of course, the biggest thing that we hear about HLS and its problems are the high latency that you usually have. And that's usually just a problem with default settings. I mean, it's just like folks who buy a Linksys router and don't change the router password from admin, and then they complain that they've been hacked. I mean, there are so many things that you can do with HLS and Dash to optimize it, to get it much lower than the default. I mean, of course, vendors here are going to advertise that, they're much lower than that 10 to 30 seconds, and I'm not saying that you shouldn't look at other vendors when it comes to their low latency HLS variants, because they are all, I would say everyone that I've looked at has a unique approach to it, and it's interesting to see how they're trying to solve those low latency times. I'm just going to break out of my my slide deck here real quick. Again, I tend to do a lot of Wowza dev for my clients, so I'm just going to show you a quick for instance. Again, I had it right up here just a second ago. Let me just pull it forward. Oh, it's right here in front of me. I just couldn't see it. So I'm in Wowza Streaming Engine right now. And if you are a Wowza Streaming Engine user, or you've utilized it before, and again, there's similar settings in other technology, just go down to your Cupertino streaming packetizer. the default chunk duration in Wowza is 10 seconds. That is why your latency is so high. You can take that down as low as your keyframe interval on your encode is going to support. So if you have a 2-second keyframe interval in your live stream encoder, your H.264 encoder, set that to 2 seconds. There's no reason why you shouldn't. Now, I shouldn't say there's no reason, but you can, I've had a medical client who has a very low bit rate video display screen that they of a monitoring device that they use in hospitals, and they get sub 1 second latency with HLS because they've got such a short keyframe interval. Wowza will now actually create keyframes from previous P frames if you need to, so you can do things like that, so you don't even have to have your encoder send it out, especially if it's fairly static video footage. So just know there's simple ways to reduce latency. I can, like, it's a no-brainer for me to take someone, like if I have a client come to me and say, hey, these HLS latencies are out of control, how do I get this down? Like, we're just going to change one setting, and automatically we are now to this particular one is you look at the playlist chunk count. So how many chunks are you listing in your playlist? There's the default for Wowza is 3. I increased this one to 4. So we've got a little bit more of a buffer in the manifest. And by buffer, I just mean play out time to switch between adaptive bit rates. But that's an 8-second latency on average. It could grow to 10 or 12 seconds, but that's cut more than half from the default 30, right? You can do math. 10 times 3 is 30. That's 30, a 30-second. Sorry, 2 times 3. I'm looking at the wrong number. The max chunk count. That's how much the server will store in reference to a playlist generation. But your playlist is going to have basically 8 seconds worth. You could try any settings you want with this. I wouldn't recommend a manifest with just one chunk reference in it because you're going to be refreshing that manifest a lot. There's going to be a lot of overhead with the calls to update that manifest. So I wouldn't recommend less than 3 chunks in a playlist, but I have clients that have taken it down to 2. And for the load that they have on their servers, it hasn't been too bad, or the clients that they have looking at it. But those are really easy things to do. You don't need someone like me to help you with that. You just need to know where to go for those kind of settings. And again, those are all, like, any good media server that's doing its job is going to be able to do that for you. Just specify that chunk count. What's nice about Wowza is that that's a target, so even if your chunks aren't able to be carved out of 2 seconds, it's going to find the closest match to that. So if I had a 3-second keyframe interval, it's going to make 3-second chunks. It just lets it know what the neighborhood is for chunks. We, of course, are going to be supporting new codec, or the codecs are already supported beyond H.264. We've got HEVC support and HLS on most iOS devices that have been around for a couple of years. Dash as well, you know, they're fairly codec agnostic containers. Well, they are by definition. It's really more about where you have those codecs installed. And again, the drawbacks out of the box, they're going to be prone to high latency. And they are generally designed for one-to-many broadcasts. You're not going to have, it doesn't matter how low you get that latency, you're not likely going to be using HLS or Dash or any kind of HTTP chunked packetized stream for a real-time conference, right? I'm not going to start trying to talk to my buddy with an HLS stream. If I was broadcasting this session live, it's perfect, right? And of course, it's TCP only, so that's just the nature of HTTP, right? So TCP will, of course, have a different kind of networking negotiation than something like WebRTC and UDP. So moving along, another player on the stage, of course, is WebRTC, and you know, this is the darling child that we're waiting to, you know, grow up to be, you know, the player that we need in this market to really replace Flash. Again, I come from the world of Flash. I wrote books like the Flash Bible, the ActionScript Bible. I built plenty of Flash applications, and I was really excited. I still am excited about WebRTC, but it's really complicated. It's not cheap to build WebRTC solutions, mainly because every time something gets built by a great open source team, some big telecom buys that company, and then they end of life that open source strategy. That's not true for some of the tech that I will talk about at the end of this. I've got a bunch of service, or rather, software packages that you can look at. Safari's finally coming to the table. I mean, this is the problem with quote-unquote standards, is that it takes a while for people to adopt standards. again, I'm used to the Flash world where I'll never forget, when I did projects for Disney, they're like, I don't know if we want to use Flash Player 8. They're only at 80% adoption. We want to wait till 90. Like, you can't even talk those numbers with WebRTC, right? Because like those, they take those numbers a lot lower. It's funny how the same mentality that applied to Flash does not apply across the board to these techs, right? Companies will adopt technologies way before they reach penetration levels that Flash Player versions did that added support to it. So it's just an interesting time right now because it just takes more time, and that's for me, as someone who grew up in the internet startup times as far as my career was concerned. I was just used to innovation picking up very rapidly because you had something that was a glue like Flash. Again, I'm not some big fan of Adobe or plugins, but I am a fan of things that allow tech to take place so we don't have to have this conversation for years on end before it's like, now it's ready because we finally got this vendor to get on board and it's supported across this whole ecosystem. Because otherwise, you're building solutions right now with WebRTC that are a lot more we're not talking about just taking CSS and making page rendering at the same scale with text across browsers. We're talking about big expensive things like video transmission, codecs, transcoding of codecs so that if I'm doing a live stream in VP9 that someone who only has an H.264 decoder can watch my stream. That's not a cheap proposition. Why can't we just have a universal codec in all browsers? Well, we can't because we don't have something like Flash to be that that technology in that stack. We've got licensing issues. Hopefully AV1 will be that, but man, the roadmap for AV1 isn't looking exciting right now, right? It could be, but again, we need people to adopt it, and we're in a world where we want everything to work across the board. So where we are with WebRTC, again, it's fairly recent. We'll be at 2 years soon from that September 2017 date when iOS 11 on Safari added some of the last bits to WebRTC so you could start to use it there. Again, thankfully WebRTC I think has learned from things that came before it like Flash and RTMP. We've got AES 128 encryption in WebRTC streams. We've got both TCP and UDP options in WebRTC. I think the biggest problem right now is just, again, the tech stack's becoming to a point where you've got developers that are just conversing in it. Right now, like I don't see droves of WebRTC developers at this conference, right? There's probably just a few, I would say there's probably a half a dozen to a dozen WebRTC developers at this conference that know what they're talking about and could build you a solution around it when it comes to the actual engineers. Of course, if you work at a company like Zoom or whatnot, you've got legions of engineers that have been working days on end, if not years on end, on their solution stack. And again, the drawbacks I've already mentioned are just right now we're still at that crossroads where we're waiting for adoption to be there for something like WebRTC, and it doesn't scale well, right? Not yet. We will see it scale. It's going to require the same kind of architectures that RTMP required to scale because these are real-time connections. You can't cache this stuff on an HTTP edge. You need sockets available on servers that can accept the user loads that you need to accommodate. The next player, of course, is RTSP. And again, when I start talking about these protocols, I'm now talking about protocols that we can use internally within mobile app development. I have an Android and iOS dev on my team that I have currently active on a project, and we had to do a lot of low-level video frame manipulation for a project we're working on. We just migrated the server stack over to Red 5 Pro, which is here. I'm glad to see Chris has brought his whole gang here to talk about Red 5 Pro. I think they're going to be an innovative leader in this space when it comes to WebRTC and RTSP. I mentioned that because in their mobile SDK, they're using RTSP in their mobile SDK. They're not the only one. A lot of mobile SDKs are using RTSP for transmission. And again, this isn't something that you need in the browser when you're talking about mobile apps. Android and other applications or other, if you're on Android and you click an RTSP link on a web page, it will launch a native player, usually on that Android device that's outside of the browser. So there are different ways to play RTSP, but when it comes to my mentioning of it here, it's more to talk about it for both a source point, like a lot of security cameras still use RTSP. I do a lot of configurations for municipal governments that have security cameras everywhere, or not security cameras, traffic cams, park cams, maybe they are security cams, I don't know, but they're supposed to be there for the public to sort of see like what traffic conditions are like. Those are like access cameras, those are all RTSP transmissions into an ingest like Wowza or Red 5. And again, RTSP has TCP and UDP options, and of course, for the lowest latency, we're looking for that UDP option, right? So that we have fire and forget and not retries like you would with TCP. And again, the drawbacks, there's no native browser support really for RTSP. Firewall and port access, that's also something that I didn't mention back with our WebRTC, but as we start to get into UDP layers and port allocations, if you thought Flash and RTMP in 1935 was a nightmare, welcome to a whole new world of port allocation and firewalls with WebRTC, right? I mean, it's going to be an interesting path to see just how I think we have come a long way with corporate IT divisions and getting firewalls updated, but it remains to be seen just how we will address port access issues to it. Again, it's difficult to scale something like RTSP. You can't use HTTP edges for that. I will continue to mention RTMP in my session until. And what's amazing about RTMP is it's going to have a life of its own, even when Adobe end of life's Flash next year, at least as they're saying it. RTMP is just a protocol. I would say, I don't have any stats on it to support this assertion, but I would say a high majority, if not, I would say 90% of so many live streams are ingested via RTMP, right? Like if you're doing Facebook Live from an encoder, they have an RTMP ingest. They just made an announcement that they're only allowing RTMP-S now because everyone wants to be secure. So that requires an SSL handshake at the beginning and encryption of those bits over RTMP. So we'll see probably some changes like that in hardware as we move forward, or any kind of software implementation. But again, that's mainly for pushing out, not so much for playback. Although again, when it comes to mobile SDKs, there's plenty of RTMP libraries out there that will enable RTMP playback in native apps. I helped, I think we did it at West last year. A client of mine does a quiz show called That's Right, and that's all RTMP, and it's a quiz show, and we usually have well under 1 second of latency. When I say well under, it's anywhere from 500 to 800 milliseconds. That's even with an edge origin architecture. They're not at millions of users yet. They probably do anywhere from 10 to 20,000 users per quiz, but we were able to build out an RTMP stack with them. And again, that I find, I haven't mentioned this before, but when it comes to low latency, there's really three factors in that whole equation. There's the encode latency, right? How are you setting up your encoder so that it's getting out video frames as quickly as possible, and audio frames as well? How is the server configured to negotiate its buffers, and how is the player configured to negotiate that buffer? I find that the single biggest problem or pain point is developers that aren't video developers not knowing how to control buffer on their playback APIs, right? So just a quick note to, if you take away anything from this, always look at buffer time. Red 5 Pro, I'm going through the learning curve on that right now. They have a great article on adjusting buffer time in their mobile SDKs, and it's probably something that, again, that it's a simple setting, right? You just reduce your buffer time to something that's acceptable, that's not gonna choke, and then you move forward with it. The biggest drawback I find moving forward, even though I don't think RTMP is going anywhere for ingest, is that it only supports H.264. You can't use HEVC with it. That's a bummer. They could evolve the spec if they wanted to, because they had to evolve the spec to allow H.264 from its original Sorensen Spark codec to its VP6 codec. Every time they added a codec to to RTMP, they had to update the spec to support it. It's just not going to be updated to support anything beyond H.264, I presume. And then I think my last player on the stage here is WebSockets. WebSockets has been around a lot longer than WebRTC as far as a browser, part of the browser stack. You can have low latency with it. It wasn't really designed for video though, so the way that folks are using WebSockets, I know that Wowza in their ultra low latency service had a WebSocket implementation. I don't know if that's still in their solution set, but again, it's going to be WebSockets are. I would say that's the fallback layer that a lot of folks I see could be using in their live streaming low latency kind of stacks, mainly again because it's a fallback. Like if you don't have a modern browser that could support WebRTC, maybe you could support WebSockets. Again, I don't know if I've seen an AV conferencing solution that works with WebSockets. I'm sure someone's got one out there, but again, it's just a socket and you can push whatever bits you want through it. And again, not designed for video specifically. Actually, it's not the last one. Sorry, the last one I was going to talk about is SRT. I think it's funny that I see people refer to secure SRT. Isn't that's a bit redundant on the secure part. Secure, reliable transport, but you don't have to have AES encryption on your SRT transmissions, but it's interesting to see that I don't know how many of you may have been at NAB this year. I don't go every year, but there was a whole panel talking about SRT, and High Vision, who helped start this whole conversation because they were, I believe, some of the first contributed some of the first open source code to SRT that's out there. Is now trying to push it as potentially a deployment protocol so that you wouldn't only use SRT for server to server or for ingest. A lot of encoders, Teradek encoders, I believe, support SRT. Since it's open source, you just need to write a new wrapper for your video and audio packets to get them out of your encoder. I haven't played with an SRT transmission yet with FFmpeg, but I'm pretty sure there's an SRT library out there. It's a little confusing because SRT is also the format that's used, used for captions. I wish they'd come up with another acronym, but if you search for SRT, you're going to find a lot of different things with SRT, so it's a bit of a bummer when you're searching for SRT in Google. And again, we have UDP available with SRT, so that's just another way to make sure that we've got low transmission or low latency in our transmission. And I think it is poised to be the substitute for RTMP moving forward, especially for encoders. It's a no-brainer that we need a new format that can support new codecs. I think SRT is going to be that transmission protocol. Again, when it comes to playback, are we going to see browsers supporting an SRT protocol so that I can play an SRT stream? I don't think it's going to happen anytime soon. Maybe if High Vision developed a plugin. No, I'm joking. So it remains to be seen how SRT is going to evolve. It's funny, last night we did a broadcast here from the Hilton of the Stream Media Advanced Forum that Dom and Eric from Stream Media Magazine run, but they did a special broadcast here from the Hilton. And it came up, David, who was here before me, when they asked him about SRT, he said it's more of a start and not a destination. So I think it's interesting that we already have industry experts looking at SRT as a good proposal, and it could serve as a stopgap. Is it going to be here long term? It's too early to say, I think, but again, you could start using SRT today for ingest. It's not there for playback, but if you're trying to get streams into your servers, you could most likely find an SRT path to it. Again, it's open source, so you could dev a solution around it. I don't think it's that complicated. Again, I haven't looked at that source code, but the fact that Wowza was able to add it pretty quickly, any company that's added an SRT feature did it pretty quickly, so I have to imagine that it was cost effective to do it. I've already alluded to this before. Not all real world options for live streaming need two-way AV, but this is going to be the biggest headache moving forward. I know the media servers like Red 5 and Wowza are having their own approaches to sort of how do we handle this live transcode on the fly, because live transcoding is great when it's one-to-many, but if you have lots of users who all have to have a particular path transcoded, right? If I'm H.264 only for a decoder and an encoder, and some other participant only has VP8 or 9 as an encoder decoder, what are you going to do? Well, they either, in a lot of tests, Red 5's got a great sample app that you can test out WebRTC with different codecs, and you could try it on different browsers. I know right now if I'm on Safari Mac and someone's on Chrome Windows, I get mixed results. They can see me, but they can't hear me, and I can hear them, but I can't see them on my. So we have these transmissions of decode and encode, right? So that's going to be a problem in the foreseeable future. And again, it's easy with VOD and live. You can pick a codec. Like most browsers will have H.264 decoders in it these days, but not all browsers have VP8 and 9 decoders in them. So that's going to be the biggest pain point. Let's go on to the next slide. So I'm going to meet the replacements. We've got a lot of vendors in this space. A lot of them are here. TalkBox and OpenTalk, they've been around a while. Twilio, Peer5, Zoom has their own platform API that you can use. Phoenix, they're here. He's actually in the one of their reps is in the back of the room here. Millicast is here at the studio. It's not the studio, at the conference. Wowza has their ultra low latency service. NanoStream has a H5 Live low latency service. So there are different vendors out there in this space vying for your business if you're needing the kind of transmissions that they're offering with their services. Of course, you could try building your own, and like I said, it's going to be an expensive proposition these days just because it depends on what targets you want to meet. The more targets you want to be compatible with, the more work you're going to have to spend on dev with it. And finding the devs that know this right now, they're not necessarily cheap devs. Even if you're going to Eastern Europe or offshore for those resources, they can be quite expensive if they're specialized resources. So you can actually look at WebRTC libraries. They're right there at WebRTC.org. Those are the libraries that you can start to build solutions for. Janus has been around for a while and is a very popular gateway. Jitsi is open source as well. Jitsi is a bit more full-featured, but again, there's learning curves with all of these. Wowza and Red 5, those are licensed technologies, but you can still build customized solutions around it. Like I've already mentioned, I've been doing Wowza custom development for well over almost, gosh, I don't think it's been a decade yet because I was still doing AMS before that. But I'm starting out, I've got my first Red 5 project with a client. We tried out some other server technologies. Again, it's a very specific medical approach where we have to have frame manipulation from cameras on mobile before it gets sent to the server, and we need low latency with it. And right now, Red 5's looking pretty good with that. Nginx has RTMP, of course. That server can do HLS. There's Nginx now has a commercial offering though, so that's sort of down. I shouldn't say downplayed, but has made. I don't know. Once a company starts to have a commercial offering of something, I find that the open source version suffers, or the community or free version suffers. They're not going to have all the latest and greatest available in it. I find Nginx RTMP works great if you just need an origin server and you're going to use something else as your edge. And then there's, I haven't actually done much testing with it. I did some samples with Live55 media server. That's more of an RTSP server. I was playing around specifically for security and surveillance transmission. But again, just there for a reference to research. Of course, at the end of the day, this is, if you need to cover all your bases, this would sort of be a fairly simple diagram of being able to accept different formats in and have all the different formats coming out of it. You're not going to get, it's not like these are all equal technologies though. A WebRTC stream is going to be, incredibly low latent compared to an HLS or Dash stream, and so these are just all the outputs that come out. You could probably see this same diagram on any of the vendors that I just mentioned, because they'll want to make their offering attractive, that they can bring in just about any formula. When it comes to the kind of Wowza architectures, or it could be a Red 5 architecture, anything else that supports the same kind of ingest that I'm used to working with, I primarily work on Amazon. That's largely just due to the fact that most of my clients come to me with existing AWS architectures. So this is an example of just, a sample architecture where you could have Wowza edges in front and also have CloudFront and other types of routing to those same services. But at the end of the day, like I mentioned, I would say the vast majority of my clients for real-time streaming, whether it's that real-time is VOD or live, are doing things as simple as this, right? We have an RTMP ingest. We put CloudFront in front of a Wowza GPU or anything. You could be an Nginx instance, whatever you want to ingest that RTP, create your transcode flavors, have CloudFront be your edge, and then away you go. There's just a quick sample of just sort of like what I actually use. I usually use an Asia Hilo encoder, or Videon is a new player in the market. They've got the Shivano. They've even got a newer device, whose name is evading me at the moment, but I've actually tested the Shivano extensively with my work that I do in live streaming, and it's played very well. And it's allowed me to play with the newer options with HEVC, because with that Videon Shivano, I will do HEVC transmission into Wowza over UDP, and then have Wowza transcode the H.264 so that then everyone can watch it. So I get the benefit of HEVC from source. Like right now, if I was trying to push a live stream, a lot of you are using a lot of bandwidth here at the Hilton, so I don't know if I would get a 3 or 5 megabit stream out. But with HEVC, I could have a little bit of assurance there that I would get it out with a higher quality than I could with H.264, and then let the server do the work for getting out a better copy of it in H.264. There's more players than that. Theo, I don't have Theo player on there, but it might as well be. Any of the players that you have here can, I would say 99.99% of the player tech out there, if not 100% of them, support HLS. It definitely has been the format that most vendors have rallied around, just again for simplicity, from a simplicity point of view, just for integration. It is possible to just do an HLS only workflow. You don't have to have several different formats. And there we go. I've got 8 minutes left, which is perfect. Thank you for coming to my session. I'm happy to take questions in the remaining time that I have. Any questions? Things you wanted answered that I didn't? The Quick protocol. Oh, interesting. I haven't played with Quick yet, but now I have a new to-do for my next slide deck. Quick. Sorry? Okay. And is that a browser-supported protocol, or is it? It is. Okay. Any other questions? Comments? Well, we can all break a little bit earlier if you want. Thank you again for coming.